Yes. Good evening, Alfaz, Harsh, Jayashri, Aditya. Good evening, beta. Good evening, and welcome to the session on Biochemistry of Carbohydrates, Part 2. So, before starting the session, I want everyone to give me a thumbs up in the chat box so that I am assured that the audio and visuals are perfectly fine. So, yeah, just give me a thumbs up in the chat box so that I'm assured that the audio and visuals are perfectly fine. Harsh says it is okay. Riya Singh, welcome to the session, beta. Welcome to the session. Yes. Aditya says yes. Alfie is okay. Jainam, very good, beta. Mr. Nobody, namaskar. Ashish, good evening, beta. Shraddha, very good. Very good. Chali, beta. Before wasting much more time, let us start with the session. So yes, already we have discussed biochemistry of carbohydrates part 1, where I have discussed about the monosaccharides yesterday and the formation of monosaccharides. Today I will be discussing about the disaccharides and the polysaccharides. Okay, I will be discussing disaccharides and polysaccharides. So yes, I hope everyone is ready, beta, with your notes, with your colored pens, with your pen, pencils, everything. Just give me a thumbs up that everyone is ready for the session. Yes, I'm waiting for your thumbs up, beta. Chaliye. Princey, okay. Perfect, beta. Yes, Harsh, chal. Start karte hain. Yeah, very good, beta. I'll face with full energy. Now concentrate, beta. Now concentrate on the disaccharides wala part. Yes, chaliye. Very good. Hmm. चल चल ठीक है ठीक है ठीक है ठीक है सुरवीन गुड इवनिंग बेटा सुरवीन गुड इवनिंग बेटा तो यस चल अंशुल hello beta hello so let us start with the disaccharides beta let us start with the disaccharides so everyone knows the fever of head good evening beta now disaccharides basically means yeah the disaccharides basically means two di means two and saccharides means sugar so you already know it is two potential sugar units. Okay, when two potential sugar units are joined together, this is called as disaccharides. Prince Panchal, yes, good evening, beta. So remember, beta, it is joining, it is joining two monosaccharides. Okay, it is joining two monosaccharides. And remember that these two monosaccharides are joined together by glycosidic bond. They are joined together by glycosidic bond. Now my question to everyone in the chat box over here, glycosidic is which type of bond beta? Glycosidic is which type of bond? Yes, I want everyone to answer. Yes, glycosidic is which type of bond beta? Yeah, I want every one of you to answer this question. Yeah, sure. Those who don't know, remember beta, the glycosidic, it is a type of covalent bond beta. Okay, it is a type of covalent bond. Okay, it is the type of covalent bond. Jainam, very good beta. It is a type of covalent bond, right? Now, remember, yeah, yes, disaccharides can be grouped into two parts. Okay, the disaccharides can be grouped into two parts. Now remember beta, we have reducing disaccharides. Reducing disaccharides. Yes, everyone is right. Anshul, right beta. And we have non-reducing disaccharide. We have non-reducing disaccharide. We have non-reducing disaccharide. So yes, now what is meant by the term reducing beta? Reducing का मतलब क्या होता है? Just try to understand from the term reducing. What is meant by the term reducing? Reducing means, see, the functional group. Now, when I say functional group beta, in case of carbohydrates, it is aldehyde or ketone, right? It is CHO or C double bond O. If the functional group, okay, it is present, okay, if it is free beta, if the functional group, if the aldehyde group, it is a functional group, you already know from yesterday's knowledge, right? If it is free, it is not taking participation in any bond formation, then we call it as reducing disaccharide. Okay, if the functional group is participating in the bond formation, then it is non-reducing. We will learn this with the help of examples also. No need to worry. The functional group is the one, okay, the functional group is the one which makes it reducing, which makes it reducing. Okay, so when I say reducing disaccharides, so remember beta, at least there should be one free functional group. Okay, one free functional group. Okay, now when I say one free functional group, so it can be either one free aldehyde group, it can be either one free aldehyde group or a free ketone group, or a free ketone group. Okay, or a free ketone group. You already know aldehyde is C double bond O H, that is CHO, and ketone it is only C double bond O. Now I want everyone to answer over here in the chat box. Aldehyde group, it is present at which carbon? Aldehyde group, it is present at which carbon, and ketone group, it is present at which carbon? So I want everyone to answer this question. चलिए जल्दी से बताइए फटाफट. Kriti says the first carbon. Very good, beta. Harsh, Jainam, Riya. Very good. Very good. It is the first carbon atom where the aldehyde group is present. Kriti, Jainam. Very good. Anshul. हाँ बिल्कुल ठीक है जैनम. सेकंड आंसर भी तुम्हारा बिल्कुल ठीक है. कृति तुम्हारा भी सेकंड आंसर ठीक है. कीटो इज द सेकंड वन. मनीष सेज 1 and 2. वेरी गुड बेटा. वेरी गुड. आशीष रोहार. वेरी गुड बेटा. परफेक्ट परफेक्ट बेटा. ऑल आर राइट. So you already know if this group it is free. Free means it is not participating in any bond. ये कोई bond बना ही नहीं रहा. Obviously बात है, if this is free, it is a reducing disaccharide, and non-reducing beta simply means, okay, when two functional groups are joined together. Okay, when two functional groups are joined together. When two functional groups are joined together. Okay, it simply means that the functional groups are engaged into the linkage. Functional groups are engaged into the linkage. Okay, and yeah, which linkage I'm talking about? It is the glycosidic linkage. It is the glycosidic linkage, right? It is the glycosidic linkage, right? So over here, beta, remember, non-reducing means no free functional groups. No free functional groups. I hope this point is clear. What is the difference between the reducing disaccharide and the non-reducing disaccharide? Just give me a thumbs up in the chat box if this particular slide is clear to you people. Then I will start with the example and I will explain beta. I will explain. So yes, चलिए बेसिक पता चल गया सब लोगों को. यस, रिया सेज ओके. चलिए आशीष वेरी गुड बेटा. वेरी गुड. अल्पेश बेटा जवाब देते रहा करो. श्रद्धा यस क्लियर. ओके वेरी बेटा. जयनाम वेरी गुड बेटा. चलिए हर्ष कृति वेरी गुड. परफेक्ट परफेक्ट बेटा. चलिए जवाब देते रहिए. मुझे पता चलता जाएगा दैट यू गाइस आर ओवर हियर. ओके, लिसनिंग टू माय लेक्चर, प्रिपेयरिंग नोट्स. Now starting with examples of reducing disaccharides. Again, I will be consolidating all the information in a form of a table. Now beta, firstly, you should know the name of the disaccharide. Now when I say disaccharide beta, it is formed from monosaccharides. So you should know the monomer units. You should know the monomer units and you should know which linkage is present. Okay, You should know which linkage is present over here, right? So the first one, beta, the first one, which is an example of reducing disaccharide, it is maltose. It is maltose. Now, can anyone tell me in the chat box? Maltose is made up of two monosaccharides. I want the name of these two monosaccharides. Yes, the maltose it is made up of. Yes, Ashish, very good. इसका बताओ what is like the monomer unit? हाँ बताओ इसका monomer unit बताओ. Yes, Priti, very good बेटा. It is glucose plus glucose. Now glucose is one monosaccharide. Now, when glucose combines with another monosaccharide, like it is the glucose only, when two glucose will combine, it will result in the formation of maltose, right? Yes, Riya. Yes, Harsh. Very good, beta. It will result in the formation of maltose. So remember, beta, the linkage that is present between these two glucose. I will show you the linkage in a couple of minutes, beta. No need to worry. So remember the linkage over here, beta, it is alpha. Just write it down for right now. Alpha 1 to 4 glycosidic linkage. Glycosidic I have already told you. Yes, glycosidic linkage. I will show this linkage beta. No need to worry. Just write it down. It is alpha 1 to 4 glycosidic linkage. Rajvardhan, very good beta. Very good. Now coming on to the next part beta. Coming on to the next part. Yes, we have the next, that is isomaltose. Now, can anyone tell me what will be the monomer unit, beta? What will be the monomer unit in isomaltose? Yes. Anyone who would like to, yeah, give his or her expert opinion on this particular case? Yes, Riya Singh, very good, beta. I'm quite impressed that you guys are taking so much active participation. You all are having like good command. Yes, beta, it is glucose plus glucose only. Now it is glucose plus glucose only. Now, what is the difference between maltose and isomaltose? It is in the linkage beta. Now, glucose first carbon to glucose fourth carbon. Okay, but here glucose first carbon atom will link to glucose sixth carbon atom. So it is alpha. Yes, it is alpha 1 to 6 glycosidic linkage. Alpha 1 to 6 glycosidic linkage. Alpha 1 to 6 glycosidic linkage. Yes, Ashish. Yes, Harsh. Very good, beta. It is alpha 1 to 6. The difference between maltose and isomaltose is in the linkage, beta. I will show these structures. Absolutely no need to worry. Now, third one, coming on to lactose. Coming on to the lactose. I want everyone to type the monomer units of lactose in the chat box. Meanwhile, I'm writing. So I want everyone to like write it in the chat box. Yes, Anshul, it is right, beta. It is perfectly right. The lactose, the monomer units of lactose, it is, yes, it is galactose. Yes, very good, Kriti. Glucose plus galactose, alphase, Jainam, Harsh, very good, beta. Very good, beta. It is gluco, or I can simply write galactose first, right? Galactose plus glucose. Galactose plus glucose. And remember, since these both structures are different, they are not glucose glucose. One is galactose and one is glucose. That's why it is beta 1 to 4 glycosidic linkage. It is beta 1 to 4 glycosidic linkage. It is beta 1 to 4 glycosidic linkage. Now coming on to the fourth part, beta. Coming on to the fourth part. Yes, we have, okay, now lactulose. We have lactulose. Now, can anyone tell me? Yeah, can anyone tell me the monomer units of lactulose? Lactulose. We will be discussing each in detail. Maltose, isomaltose, lactose, lactulose, everything in detail. No need to worry about that. So remember, beta, the monomer units in case of lactose. Okay. Yes, very good. It is galactose, beta. It is galactose plus fructose. The difference between lactose and lactulose. Lactose, it is galactose and glucose. Lactulose, it is galactose and fructose, and there is no linkage as such shown over here. No linkage. Nothing is there. Okay. Can anyone tell me the reason why? Yes. Lactulose is a synthetic disaccharide beta. It is a synthetic disaccharide. Okay. It is a osmotic laxatives. Okay, we are using lactulose in pharmacological industries. Okay, we are using this in pharmacological industries. Yes, in liver diseases especially, we give lactulose, right? So yes, that was about the reducing disaccharides. I hope till now it is clear. Beta, फटाफट से thumbs up दे दो chat box में. I hope till now it is clear. Beta, just give me a thumbs up in the chat box. Sure. वेरी गुड हर्ष कृति अल्फेज आशीष रिया परफेक्ट परफेक्ट बेटा चलिए राजवर्धन वेरी गुड नाउ कमिंग ऑन टू द नॉन रिड्यूसिंग डाइसेक्राइड्स अंशुल वेरी गुड बेटा वेरी गुड नॉन रिड्यूसिंग डाइसेक्राइड एग्जांपल्स so remember beta again the same table that I will try to form now when I say non reducing beta you already know that there will be no free functional group okay there will be no free functional group no free functional group ना तो एल्डिहाइड ग्रुप फ्री होगा ना ही कीटोन ग्रुप फ्री होगा देयर विल बी नो फ्री फंक्शनल ग्रुप राइट सो यस नाउ कमिंग ऑन टू द नेम ओके अगेन विल ड्रॉ द सेम टेबल बेटा द monomer units and the linkage now now the very first example that we will talk about it is sucrose. Now can anyone tell me in the chat box what are the monomer units of sucrose? Yes Kriti Ashish very good beta can anyone tell me what will be the monomer units? Yes Kriti very good it is glucose plus fructose okay it will be glucose plus fructose. It will be glucose plus fructose, right? And remember, beta, over here the linkage will be different, beta. It is alpha 1, okay, to beta 2 linkage. Alpha 1 to beta 2 linkage. I will show this linkage, beta. No need to worry as of now. Just write it down. Just fill this table and in like another 2 minutes, I will show every linkage, okay? The second one beta, it is trehalose. It is trehalose. And remember, it is made up of, yes, it is made up of glucose. Yes. Tell me if anyone want to answer trehalose, it is made up of what beta? Glucose and, yes, it is made up of glucose and glucose only. Now beta what is the difference glucose और glucose से तो maltose भी बना है isomaltose भी बना है now what is so specific about the trehalose yeah what is so specific about trehalose beta remember it is having alpha 1 to 1 linkage alpha 1 to 1 linkage alpha 1 to 1 linkage yes alphase yes Shraddha very good it is the linkage part that is specific to that glucose का पहला carbon the first carbon of glucose will be linked to the first carbon of another glucose right so we will try to draw each structure okay we will try to draw each structure one by one I hope till now the concepts of disaccharide the concept of reducing disaccharide non-reducing disaccharides the formation like I mean the monomer units and the linkage it is clear to each and every one right now just give me a thumbs up Pita. I don't know the class. Why, Anshum, you didn't know the class? The class was scheduled at 6:30 today. Yes, Harsh, very good, beta. Very good. Jainam, Ashish, Riya, Alfez, very good, beta. वेरी गुड। चलिए 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 रिया अल्फेज बाकी भी आंसर करते रहा करो, थोड़ा पता चलता जाए कि तुम लोग क्लास में बैठे हुए। नो बेटा, यू ऑलरेडी नो maltose. Now specifically if we talk about the maltose, you know the maltose is a reducing disaccharide. Okay, Shraddha, very good beta. It is a reducing disaccharide. Now when I say reducing disaccharide, it clearly means that there will be a free functional group. Free functional group or functional group, either it can be CHO or C double bond O. Now, and what is the linkage beta over here in maltose? You already know it is alpha 1 to 4 linkage. Alpha 1 to 4 linkage. So, you already know it is formed from two monomer units. It is formed from two monomer units. We have glucose plus glucose, right? So let us draw the structure of glucose. Okay, so let us draw the structure of glucose. Now OH, okay, in the structure of glucose, the OH, okay, will be, okay, one OH, which is like specific. It will be at which carbon beta? चलो जल्दी से बताओ, जल्दी से बता दो फटाफट से। Yes, Jainam Harsh, very good beta. It is the third carbon. It is the third carbon. So let me just label it beta. It is 1, 2, 3, 4, 5, 6. Glucose में 6 carbon होते हैं, C6H12O6. So yes, at the first carbon, you already know we have the functional group, that is the aldehyde group CHO, right? CHO. All the OH will be towards the right side except the third one, and the OH at the third place, it will be towards the left side. At the third carbon, yes, everyone is right. Now, automatically, you already know to balance it, like we have to put H at every place. Yeah. So, yes, you already know this, right? You already know this. Now, taking another glucose beta, taking another glucose because it is combined. Okay, two glucose are combined together to form this, right? So again, drawing the same structure, and I want each one of you to draw the structures beta. I want each one of you to draw the structures. Yes. Now, when I say beta, alpha 1 4 linkage. Now, you already know this is glucose. Okay, you are already aware that this is glucose and this is also glucose. Okay, this is also glucose. Now, both. Okay, now when I say yes, alpha 1 to 4, you can see, yeah, CHO over here, it is at first carbon. Okay, the first carbon of the first glucose, it will react with the fourth carbon of the second glucose. It will react with the fourth carbon of the second glucose. So this linkage beta over here, it is called as the alpha 1 to 4 linkage. Alpha 1 to 4 linkage. Okay. Alpha 1 to 4 linkage. क्या ये बात क्लियर है सब लोगों को? Is this point clear to everyone? First carbon will react to the fourth carbon of both the glucose. ये obviously बात है, ये भी ग्लूकोज है और ये भी क्या है, ग्लूकोज है, ये भी ग्लूकोज है. हर्ष, रिया, वेरी गुड बेटा, वेरी गुड. चलिए, ये क्लियर है सब लोगों को? चल अब, हाँ, Now beta, how to form? Yes, everyone is right. Ria, Alfaz, Jainam, very good beta, very good. Yeah, everyone is right. Now let us now focus on the structure, how the maltose will look like, how the maltose will look like. So the glucose, you already know the ring structure of glucose. Okay, it is a six membered ring with five carbon and one oxygen. You already know this beta. It is a six membered ring with five carbon and one oxygen. So yes, you are already aware of this particular thing, right? So we have the first carbon, the second carbon, the third carbon, the fourth carbon, and the fifth carbon. Okay. And yes, you are already aware that over here the H will be over here. OH will be here. Second place also the H will be here. OH will be here. Third place OH will come up because it is on the left side, right? It is on the left side. And H will come down. Otherwise, on other cases, everything remains the same, right? At fifth carbon, it will be, yes, the H will be here, and you already know the fifth one, it is attached to the sixth carbon, that is CH2OH. लास्ट वाले को अगर लिखेंगे तो इट इज CH2OH ओनली, राइट? इसको हम लोग क्या लिख सकते हैं? CH2OH, CH2OH, यस, CH2OH. अब इसी के साथ we have to combine one more, okay, one more glucose. So again I will draw the same structure, one more glucose beta. Okay, so yes, now removal of which molecule beta will result in the formation? Meanwhile you type, I will just complete the structure. Okay, removal of which molecule will result in the formation of maltose? चलिए फटाफट से आंसर दीजिए इस क्वेश्चन का. Meanwhile I will just try to complete the structure. Yes, चलो आंसर दो फटाफट से. हाँ, now beta see over here. हाँ, now beta see over here. Yes Kriti, very good beta. It is the water molecule that will be removed. It is the water molecule that will be removed. Now you already know that, okay, that this is the first carbon and this is the fourth carbon. So linkage will be between the first and the fourth carbon. Yes, Kriti, Shraddha, Mohammed Yasir, very good. Linkage will be between the first and the fourth carbon beta. From the first carbon, the hydrogen, and from the fourth carbon, OH will be removed in the form of a water molecule. So it will be minus H2O. It will be minus H2O, and the removal is taking place between the first and the fourth carbon. The first and the fourth carbon. So you will get the desired structure beta right now. And remember, the structure will look like this. This question has been asked in the exam multiple number of times. I'm not drawing the whole again structure over here, but remember it is, yeah, it will look somewhat like this. So yes, over here you can see, yes, over here you can see that this H will be left and this oxygen is left beta over here. So this oxygen will be joined like this to this particular structure, right? So this is something which is called as the maltose. This is something which is called as the maltose. Okay. So I hope this bonding is clear to each and everyone. फटाफट से आंसर दीजिए, जल्दी से बताइए in the chat box. फटाफट से chat box में बताओ. जय नाम says yes sir, it's clear. What about rest beta? What about rest? Riya Singh, chalo, very good beta. Harsh, Ashish, Rajwardhan, Kriti, Alfes, very good beta. Shraddha says yes sir, it's clear, chaliye, perfect, perfect, perfect beta. now बेटा आइसोमैल्टोज में क्या करोगे? आइसोमैल्टोज का स्ट्रक्चर मुझे बताने की भी जरूरत नहीं है बेटा. दिस इज होमवर्क फॉर यू टू ड्रॉ नाउ आइसोमैल्टोज. नाउ यू ऑलरेडी नो आइसोमैल्टोज में क्या होगा. द फर्स्ट कार्बन will be reacting with the sixth carbon. The first carbon will be reacting with the sixth carbon. Princey, very good beta. The first carbon will be reacting with the sixth carbon. It is alpha 1 to 6 linkage. Alpha 1 to 6 linkage. Yes, Ashish. Very good beta. It is alpha 1 to 6 linkage. And this is for isomaltose. This is for isomaltose. And this is something that you will draw it in your registers in your notebooks, okay? And just leave space for isomaltose also, right? Please complete your notes. I've already discussed one from your side, okay? So it's a contribution, right? Now coming on to the next structure, that is lactose. Lactose. Now beta, why beta? Okay, why maltose is a reducing disaccharide? We have not come to this point. Yes, can anyone tell me the free functional group, it is present in which glucose? The first glucose or the second glucose? I want this answer in the chat box. The free functional group, it is present in which glucose? First or second? चलिए बताइए, जल्दी से बताइए. The free functional group, it is present in which glucose? First or second? बेटा देखो ना, free functional group कहाँ से कहाँ दिखाई दे रहा है? कृति से second. चलिए, वेरी गुड बेटा. बेटा ऑब्वियस सी बात है ना बेटा, खुद ध्यान से देखो, कृति ने बिल्कुल सही आंसर दिया है बेटा. यू कैन सी द फ्री फंक्शनल ग्रुप इन द सेकेंड ग्लूकोज. सेकेंड ग्लूकोज का एल्डिहाइड ग्रुप देखो, ये फ्री है ना. सेकेंड ग्लूकोज का एल्डिहाइड ग्रुप देखो, इज इट फ्री? इट इज फ्री. बेटा जो लोग फर्स्ट आंसर कर रहे हो, आप मुझे एक बात बताइए, फर्स्ट वाला तो इट इज पार्टिसिपेटिंग इन द बॉन्डिंग ना. फर्स्ट वाला तो इट इज पार्टिसिपेटिंग इन द बॉन्डिंग, वो फ्री कैसे हुआ? तो वो फ्री कैसे होगा, राइट? सो द फ्री फंक्शनल ग्रुप, इट इज द सेकेंड glucose, okay, the first carbon, okay, the aldehyde group. That's why beta, it is a reducing disaccharide. That's why it is a reducing disaccharide. क्या ये चीज समझ में आई सब लोगों को? क्या ये चीज समझ में आई कि why we are calling it reducing? Because the second glucose का जो functional group है, that is the aldehyde group, at the first position it is free. It is not participating at any bond, in any bond, right? Kriti, Harsh, Ashish, very good बेटा. तो फिर वन क्यों आंसर किया तुम लोगों ने, कुछ कुछ लोगों ने? चलो चैनाम, वेरी गुड, वेरी गुड. थोड़ा सा दिमाग लगाना ना बेटा, थोड़ा सा, ठीक है? चलो इस वाले का आंसर बताओगे, नहीं तो फिर मैं गुस्सा हो जाऊंगा. चलो जल्दी से फटाफट से बताओ. लैक्टोज विल बी फॉर्म्ड फ्रॉम, yes, lactose will be formed from galactose and glucose. Galactose and glucose, right? Galactose and glucose. Okay. Now, galactose का स्ट्रक्चर बताइए बेटा. Galactose, at which carbon atoms the OH will be at the left side? Now, at which carbon atoms the OH will be on the left side? चलो जल्दी बताओ, ध्यान से जल्दी बता दो फटाफट. ये सबको बताया है मैंने कल. आई हैव ऑलरेडी टोल्ड दिस इन द चैट बॉक्स, आई मीन इन द क्लास यस्टरडे. यस, थ्री एंड फोर्थ. हाँ, फोर्थ पे भी और थ्री पे तो ऑटोमेटिकली है. यस, फोर्थ फोर्थ, वेरी गुड, वेरी गुड. प्रिंस, जयनाम, राजवर्धन, आशीष, हर्ष, बिल्कुल ठीक लिखा है बेटा. सो यू ऑलरेडी नो द थर्ड कार्बन विल कंटेन OH over here, the OH over here, whereas all the OH will be on the right hand side, right? So yes. So Yeah, just naming it. You already know it is first carbon, second carbon, third, fourth, fifth, and sixth. Again, if we just try to draw, okay, if we just try to draw the glucose beta, you already know it is C double bond OH. Then we have again the six carbons, right? The OH, it is on the right side of each carbon except the third one, which is at the left. Otherwise, yes, it is on the third carbon, it is to the left. Now, beta, when I say, okay, can anyone tell me what is the linkage present over here? I want everyone to answer me what is the linkage which is present over here. What is the linkage which is present over here, beta? Chal. 1 to 4. Very good. Beta 1 to 4. Yes, beta 1 to 4. You already know, beta. You already know that we have first carbon. It will react to the carbon of the fourth. Okay. So that is something referred to as the beta 1 to 4 linkage. Beta 1 to 4 linkage. Yes, it is beta 1 to 4 linkage. हाँ, अब बीटा क्यों है बेटा? आपको खुद ही पता है, एक कंपाउंड है ग्लूकोज, ओके, और एक कंपाउंड है गैलेक्टोज. सो दिस वन इट इज गैलेक्टोज. एवरीवन इज राइट बेटा. अल्फेज, अंजुम, प्रिंस, हर्ष, आशीष, कृति, राजवर्धन, श्रद्धा. वेरी गुड बेटा. एंड द अदर वन इट इज द ग्लूकोज. ग्लूकोज, राइट. चल, अगर इसका रिंग स्ट्रक्चर देखे बेटा, अगर इसका फटाफट से रिंग स्ट्रक्चर बना के देखूं मैं, so you are very well aware. Again, I will not mark each and everything beta. You have to be like perfect in drawing the diagrams as of now, right? So yes, so this is the galactose and this is glucose. चलो, अब आप लोगों को पता है, ओके, यस, ओके, at the first carbon beta, at the first carbon, okay, चलो, अब मुझे फटाफट से बताओ कि ओके, या H will be over here. Yes, the OH will come here. Okay, the second carbon OH will be down. The third carbon, the OH will be at top. Fourth also at top. Okay, and the fifth will be attached to the sixth carbon, that is CH2OH. CH2OH. Yes, very good, Peter. Very good, Harsh, very good. Yes. Now over here you already know glucose का तो मुझे बताने की भी जरूरत नहीं है. You are very well aware with the fact. It will be like this only. Right? So yes. Remember beta, the water molecule removal will take place. Yes, the water molecule will be removed. Okay, or I would just simply say the oxygen will remain over here. Yes. So we have minus water molecule, and again this will result in the formation of the same structure bit. Okay, so it will be somewhat like this. The oxygen will be linked. Yes, the oxygen will be linked over here to the hydrogen. So yes, this is something which is referred to as the beta 1,4 linkage. First carbon linked to the fourth carbon, beta 1,4 linkage. Okay, the beta 1,4 linkage. Yes, glycosidic linkage. I hope this is clear to everyone. I hope this is clear to everyone beta over here. Yes. Just give me a thumbs up beta if it is clear to everyone. Yes. Okay. Perfect. Perfect. Perfect beta. Now coming on to this. Okay. लैक्टोज के बारे में ना दो तीन चीजें आप लोगों को याद रखनी है. लैक्टोज के बारे में 2-3 पॉइंट्स दैट यू हैव टू लाइक मेंशन इन योर नोट्स बेटा. Medically important. Medically important. Yes. Lactose, if we talk about beta lactose, if we talk about galactose and glucose, galactose and glucose, if the lactose it is formed from galactose and glucose, it is like a natural glucose, it is naturally seen, it is naturally seen. Now when I say lactulose beta, now when I say lactulose, okay, lactulose, it is galactose plus fructose. It is galactose plus fructose beta. And you are very well aware that it is a synthetic disaccharide. It is a synthetic. Man-made हो गया ना ये? Synthetic disaccharide. Okay. It is used in pharmacological industry. Okay. It is used in pharmacological industry. It is called as osmotic laxatives. When you will discuss pharmacology, okay, in the second year you will learn that in liver diseases, okay, we give laxatives, and these laxatives are nothing but lactulose only, okay, and these are used in pharmacology as drugs. Okay, so that is one takeaway point from this slide, right? Now coming on to the next one beta, that is the sucrose. That is the sucrose. Now that is the sucrose. So beta sucrose, I will just draw the structure over here, the cyclic structure. The sucrose, it is formed from which two units? जल्दी से बताइए. The sucrose, it is formed from which two units? हाँ, it is a non-reducing sugar क्योंकि इसमें कोई भी free functional group नहीं होता. It is a non-reducing. Okay, while lactose is a reducing sugar, okay, the free functional group, it is present on which carbon? I mean, which okay, monosaccharide. The free functional group, it is present on which monosaccharide over here? Kriti says glucose. Very good beta. The free functional group you can easily see. Yes, easily see in the glucose over here. That's why beta, it is a reducing disaccharide. 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 Yes, everyone is right for the non-sucrose wala part. It is the non-reducing because all the functional groups are engaged in linking. And remember that it is formed from the glucose and fructose. Glucose and fructose. चलो इतना क्लियर है सब लोगों को. तो फटाफट से इसका स्ट्रक्चर बना के देखते हैं. इसका स्ट्रक्चर बना के देखते हैं. रिंग स्ट्रक्चर ही बनाता हूँ डायरेक्ट. रिंग स्ट्रक्चर ही बनाता हूँ. If you have time, you can draw the linear structures, but linear structures I have already discussed beta yesterday. बहुत डिटेल में डिस्कस किया. So just to save time, you should know that yes, this is the structure of the glucose. और ये तो आप तुम लोगों को learn हो जाना चाहिए. You should learn by now. So yes, it is the first carbon, the second carbon, the third carbon, the fourth carbon, the fifth one which is linked to the sixth carbon, that is CH2OH. So at the first carbon beta, you are very well aware that yeah, the OH will be over here, right? The H will be on the top. Second also OH down, H up. Third OH will be up because left side पे होता है. Yes, at all other places it will be the same, right? So I hope this is clear. This is the structure for glucose. This is the structure for glucose. Now we already know we have to draw fructose as well. We have to draw fructose as well. So yesterday I have already told you, okay, what is the name of the ring? Okay, fructose का जो cyclic ring होता है, what is the name of that cyclic ring? हाँ, ये ठीक है, प्रिंस, ये तो ठीक है. Very good, Harsh. Very good, beta. It is furanose. Very good. Very good. Ashish, fructose. Yeah, furanose. Very good. Very good, beta. So yes. Yes, you already know this is the second carbon and this is the fifth carbon. This is third, this is fourth. So yes, at the second carbon, basically the CH2OH will be over here. Yeah, because it is attached to the first carbon and OH will be at the top, right? So yes, the third carbon, yes, the OH will be down. Yes, sorry, the OH will be up, H will be down. Fourth carbon, OH will be down and H will be up. And at the fifth carbon beta, H will be down and yes, we have CH2OH. Yes, everyone is right. Ria, Kriti, Alfez, Anshul, Prince. Very good, beta. Very good. Now, what we have to do, we have to form sucrose, beta. Sucrose is simply formed, okay? OH from the first, okay? OH from the first, yeah, the first, yeah, carbon, okay, from the glucose, okay, and hydrogen from the second part will be removed, okay, will be removed, and yeah, so yes, the first carbon and the second carbon, you already know the first carbon of glucose contains aldehyde group, the second carbon contains the keto group. So yes, in the form of water, when both the bonds, I mean both the functional groups are involved in the linkage, so there is no free functional group which is remaining in the structure. So that's why it is a non-reducing sugar. Okay, no functional group. No functional group. So yes, I need not to draw the whole structure again. So yes, remember that there will be just an oxygen linkage which will be present. And this is something which is referred to as the alpha, okay, 1 because it is from the glucose part, and beta 2, it is from the fructose part, the second carbon atom linkage. Alpha 1 beta 2 linkage. Alpha 1 beta 2 linkage. I hope this is clear to each and everyone. I hope the structures of lactose, sucrose, maltose, isomaltose, it is clear to each and everyone. The examples of disaccharides, okay, reducing and non-reducing, and the concept of disaccharides. Just give me a thumbs up in the chat box if it is clear to each one of you, beta. If it is clear to each one of you. Yes, Kriti, Jainam, Raj, Ashish, Harsh, Shraddha, very good, beta. Very good. Shall. Perfect. Shall. Alpesh, Anshum, Prince, Anshul, Surveen, Rajvardhan, very good, beta. Very good. Hazira, very good, beta. Now, beta, coming to tree halos. So, remember, beta, when we say tree halos, you should be aware of the fact that it is formed from glucose and glucose only. It is formed from glucose and glucose only. But what is the difference, beta? It is C1 to C1 linkage. अब ग्लूकोज में भी 6 कार्बन होते हैं बेटा. Glucose contains 6 carbons, right? And suppose this is the first glucose and this is the second glucose. Now, the first glucose contains aldehyde group at first position. The second glucose contains aldehyde group at first position. So the linkage is between the first carbon of the first glucose and first carbon of the second glucose. So will there any functional group left behind? No. So tell me, beta, it is a reducing or a non-reducing disaccharide? Tell me, it is a reducing or a non-reducing disaccharide, beta? So remember, beta, it is alpha 1 to 1 linkage. Alpha 1 to 1 linkage. Yes, it is a non-reducing. Very good, Ria. Very good, beta. It is a non-reducing. Shraddha, very good. Harsh, Jainam, Riya, Kriti, Raj, very good, beta. It is a non-reducing disaccharide. Okay. So remember, it is alpha 1 to 1 and it is the glycosidic linkage. It is the glycosidic linkage. Right? It is the glycosidic linkage. That is something that we have to remember. Okay. So we are over with the disaccharides. Now coming on to the polysaccharides. Now I want everyone to answer in the chat box. Polysaccharides means sugar units more than what number we will consider it as polysaccharides. Tell me the number, beta. Jaldi se bata do. Yes, it is more than 10. Harsh, it is 10. हाँ, very good. Janam beta ये 10 है. It is more than 10 sugar units. It is more than 10 sugar units. Okay, it is more than 10 sugar units. And remember, the polysaccharides are classified into homopolysaccharides, and we have heteropolysaccharides. Heteropolysaccharides, right? We have homopolysaccharides and heteropolysaccharides. Now homo का मतलब क्या होता है? Same. Homo means same. These are also called as homoglycans. Okay, these are also called as homoglycans. And hetero का मतलब क्या होता है? Different. So these are also called as heteroglycans. Okay, heteroglycans. Or when I say homoglycans beta, so I am typically talking about that it contains one type of sugar. It contains one type of sugar, or I can simply say monomer units. Okay, it contains one type of monomer units. Okay, that's why it is called as homopolysaccharides or homoglycans. Heteroglycans beta, it contains different, okay, or different, or I can say more than one type of more than one type of monomer units. More than one type of monomer units. So remember beta, homopolysaccharides, if we talk about the examples, and that examples we have to discuss in detail beta, that examples we have to discuss in detail. The very first one beta, it is the glycogen. It is the glycogen. Then we have starch. Then we have cellulose, inulin, and then we have chitin. Examples of heteropolysaccharides are glycosaminoglycans, glycosaminoglycans. Okay, these are commonly called as GAGs. Glycosaminoglycans. These are commonly called as GAGs. We have agarose, and we have pectin. So the homopolysaccharides, the examples are glycogen, starch, cellulose, inulin, and chitin. Whereas when we talk about the heteropolysaccharides, we have glycosaminoglycans, GAGs. We will take it as a separate topic, agarose and pectin. Okay. I hope everyone has written up till here. Just give me a thumbs up in the chat box. I hope everyone has written up till here. Just give me a thumbs up in the chat box बेटा. जल्दी से एक thumbs up दे दो अगर सब ये सब लिख लिया है तो. चल चलो. हर्ष, अल्फेस, राज, वेरी गुड बेटा. रिया, प्रिंस, राजवर्धन, वेरी गुड. चलो अंजुम, वेरी गुड बेटा. चलो अब थोड़ा सा थ्योरी लिखेंगे और डायग्राम्स बनाएंगे. थ्योरी और डायग्राम्स थोड़ा सा कंसंट्रेट करो यहाँ पे. नाउ रिमेंबर बेटा, द ग्लाइकोजन इट इज मेड अप ऑफ अल्फा डी ग्लूकोज. अब ये डी और एल ग्लूकोज क्या होता है? आई विल टॉक इट अबाउट टुमारो. Right now just mention that it is made up of alpha D glucose. Okay, so you already know when I say polysaccharides means okay, the monomer unit is glucose. It is more than 10 glucose. When all these glucose will combine together, it will be glycogen. Right? So remember beta, it is a branched polymer. It is a branched polymer. Okay, branched polymer. And remember, it is storage form. It is storage form of carbohydrates in Yes, everyone is right, beta. Yes, it is storage form of carbohydrates in animals. And you already know that's why the glycogen it is termed as animal starch. Animal starch. So storage form of carbohydrates in animals, right? Now remember, beta, the glycogen. Okay, in our body there are two sites, beta. Okay, where the glycogen is stored. We are discussing biochemistry, so I want everyone to write those two sites in the chat box. Yes, glycogen is stored in two sites. Chalo, I want everyone to write this. I want everyone to write this. Glycogen is stored in two sites, beta, in our body. The first one, it is the, yes, it is the liver, and the second one, beta, it is the muscles. The second one, it is the muscles. Okay, yes, Kriti, very good. We have liver and muscles as the two sides in our body. Shraddha, very good, beta, very good. It is the two sites in our body where the glycogen is stored. Okay, so you already know, yes. Now, when I say glucose, okay, the glycogen as a branched molecule, beta, you are very well aware that I'm simply saying that suppose this is glucose, this is glucose, 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 glucose. Okay, so these glucose are linked together. Okay, so these glucose are linked together, and these glucose are linked via branches also. Okay, they are linked via branches also. So you already know that yes, between glucose and glucose beta, one bond is present, that is alpha 1 to 4 linkage, linear structure of glucose. I mean, linear chain. In the linear chain, when a glucose is joining with another glucose, okay, it is forming direct linkage, that is alpha 1 to 4 linkage. Now, whenever glucose is okay joining at branches, okay, at branches specifically, beta, at branches, it is alpha 1 to 6 linkage. It is alpha 1 to 6 linkage. Both are glycosidic linkage, beta. Branches पर भी ये भी glucose है, ये भी glucose है. But whenever a branch is created, beta, yes, whenever a branch is created, over there you will get 1 to 6 in the linear structure. Yes, again मैं बोलूं यहाँ पे और यहाँ पे कौन सा linkage होगा? It is alpha 1 to 4 only, but only at the branching side, beta, it is only at the branching side where you will get 1 to 6, only at the branching side, right? I hope this particular concept is clear to each and everyone. फटाफट से thumbs up दे दो if this concept is clear. I hope this concept is clear. When I say it as a branched polymer, okay, we have everything is glucose because it is a homopolysaccharide. It is a homopolysaccharide. Harsh, Chainam, Raj, Riya, Alfez. Very good, beta. So yes, yes. Two sides आप लोगों को ने बताया, that is the liver and the muscles. So you are very well aware, beta. If we talk about the liver, you already know the liver has two lobes, the right and the left lobe, and we have the muscles. Okay, the muscles. So this is the हमारा प्यारा liver, and this is the muscles. Muscles. So glycogen is basically stored in these two sites, right? Now in liver beta, remember the glycogen is stored as aggregates. It is stored as aggregates of beta particle. Okay. For time being, just remember the term. These are aggregates of beta particle. Okay. These are also called as the rosettes of beta particle. These are the rosettes of the beta particle. Okay, and in muscles beta, remember it is a single beta particle. It is a single beta particle, and remember in the form of beta particles, And remember one thing, beta, single beta particle, the single beta particle has 60,000 glucose units. It has 60,000 glucose units. So this question you should remember. Okay. In liver, these beta particles are aggregated and then they are stored in the form of a rosette, right? In muscles, it is beta particles, and a single beta particle in muscle, like it is containing 60,000 units of glucose. Okay. Now, my question to you over here, which has been asked in the exam multiple number of times, total content of glucose, it will be, okay, where it will be more, in liver or muscle? Chalo answer, दिमाग लगाओ और थोड़ा सा आंसर दो. Total content of glucose, it will be where, it will be more where, in the liver or muscle? Chalo answer to this question ka two questions over here. So the first question, it is total content of glucose. Now remember beta, the total content of glucose, it is, yeah, it is more in the muscle. Remember, it is more in the muscle. बेटा मैंने अभी बताया एक बीटा पार्टिकल में 60,000 ग्लूकोज यूनिट्स है. इट इज नॉट देयर इन द लिवर, राइट? लिवर में इट इज अप्रोक्सीमेटली लेस. ओके, अगर मैंने क्वेश्चन दूसरे तरीके से पूछा होता, इफ आई वुड हैव आस्क्ड इन अनदर वे, व्हाट इज द परसेंटेज बाय टिश्यू वॉल्यूम? What is the percentage by tissue volume? I mean, the content of glucose is more. If we talk about percentage by tissue volume, beta, remember the glycogen, it is more in liver. Glycogen is more in liver. Okay, the glycogen, it is more in liver. See beta, rosette of beta particles are highly condensed, they are highly packed. Okay, the rosette of beta particles are highly condensed, they are highly packed. Okay, that's why it is like the percentage by tissue volume, okay, that is more in case of liver, whereas total content, it is more in muscles, more in muscles. Yes, I hope this particular point is clear. Glycogen wala point clear hai? Yes, 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 yes beta. हाँ, ठीक है. मसल में बेटा एक चीज देखो कि अगर मैं एक सिंगल बीटा पार्टिकल बोल रहा हूं तो ऑब्वियसली 60,000 ग्लूकोज बहुत ज्यादा है. ठीक है. और हाँ, comparatively it is very much lesser in that, right? So yes, coming on to the starch. Now starch is the storage form of carbohydrates in what? चलो इसका आंसर दो. Starch are storage form of carbohydrates in what? चलो जल्दी दो. It is storage form of carbohydrates in plants. It is storage form of carbohydrates in plants. Okay, we have two types of starch. We have amylase and amylopectin. Amylopectin. We have amylase and amylopectin. Yes, everyone is right. Shraddha, Rama, Raj, Harsh. Okay. Now, can anyone tell me what is the difference between amylase and amylopectin? Can anyone tell me what is the difference between amylase and amylopectin? Remember, beta, amylase, it is soluble. Amylopectin, it is insoluble. Amylopectin, it is insoluble. Amylase, beta, it is unbranched. Amylase, it is unbranched. And amylopectin, it is branched. Okay, amylopectin, it is branched. Now, if you want, beta, if I just draw and explain, you can see that this amylase, it is formed from the glucose molecules. Okay, it is formed from the glucose molecules, and these glucose molecules are like arranged like this. Okay, these glucose molecules are like this only. Okay, we have these glucose molecules. Okay, so they are arranged like this. So yes. Now, okay, so yeah, these are unbranched. Yeah, beta, there are many differences. Yes, there are many more differences, but we will discuss those which are relevant, like which are useful as of now for us, right? So if we say branched beta, it is simply like these are glucose molecules. Yes, and these glucose molecules are branched. Yes, I hope this is clear. I hope, yes, Prince, it is right. I hope this is clear, beta. I hope this is clear. The starch is clear. Amylose and amylopectin. Amylase and amylopectin. Yes. Now, coming on to the cellulose. बेटा एक thumbs up दे देना जरूर chat box में. Prince very good बेटा. Raj very good बेटा. एक thumbs up दे दिया करो chat box में so that I am satisfied that you guys are at least noting and understanding each and every point that I am discussing over here. Now coming on to the cellulose, Harsh Alfez, very good beta. Rajvardhan, Zia, Anshum, very good beta. Perfect. Chalo, coming on to the cellulose part beta. Cellulose, you already know it is the major dietary fiber. It is the major dietary fiber. And remember, it is beta D glucose. It is beta D glucose. Okay. Now, when I say beta D glucose, I'm simply talking about beta 1 to 4 linkage. Beta 1 to 4 linkage. Okay. You already know humans. Okay. The humans lacks enzyme to hydrolyze beta 1 to 4 linkage. Okay, so human lacks enzyme beta 1 to 4 linkage. That's why we cannot eat, no, we are not cows and buffaloes. Like we don't eat that because this enzyme beta, if I'm just talking about the enzyme, it is the cellulase, as rightly said by Kriti. Yes, it is the cellulase which is deficient in our body. So this enzyme helps to hydrolyze this bond, but unfortunately we don't have this enzyme in our body, and that is the reason why it is not digestible in our body. Okay, so that was about the cellulose. Coming on to the chitin beta. Chitin, it is found in the exoskeleton of what? Now answer beta. Chitin is found in the exoskeleton of what? I want answers from everyone in the chat box. So remember, the chitin, it is found in exoskeleton. It is found in the exoskeleton of insects. It is found in the exoskeleton of insects. Right? It is found in the exoskeleton of insects, and it is composed. It is also called as N-acetyl glucosamine. Okay, it is also called as N-acetyl glucosamine. Okay, NAG. So it is found in the exoskeleton of insects and it is N-acetyl glucosamine. Right? Yes, Prince Anshul, very good beta. Very good. Now coming on to inulin beta. Remember that inulin, it is a homopolysaccharide. It is a homopolysaccharide. It is very important. Okay, इससे काफी बार क्वेश्चन आया है एग्जाम में. Yes, हाँ, इससे काफी बार क्वेश्चन आया है एग्जाम में. So you have to remember beta, it is polymer of beta D fructose. It is polymer of beta D fructose. D fructose, L fructose बेटा अभी जब मैं कराऊंगा आके नेक्स्ट क्लास में आपको पूरा yeah, we will learn D and L type. Okay, so no need to worry. Yes, polymer of beta D fructose, it is fructosen. Okay, Remember beta, in our field, what is the importance? It is used as an external agent. It is used as an external agent to check for GFR. It is used as an external agent to check for GFR. Now I want the full form of GFR in the chat box. Everyone, I want the full form of GFR in the chat box. And the test beta, and the test, it is called as the inulin. Yes, Prince beta, it is glomerular filtration rate. It is the glomerular filtration rate. Okay, GFR check करने के लिए it is used as a dye beta. It is used as an external agent, and that test, it is called as the inulin clearance test. Again, clinical point that has to be remembered beta. Okay, so inulin, it is a homopolysaccharide. It is a polymer of beta T fructose. Fructose P, you already know it is a monomer. I mean, the monosaccharide. Anshul, Raj, Harsh, very good, very good. Glomerular filtration rate, GFR का फॉर्म फुल फॉर्म तुमको पता होना चाहिए बेटा. Yes, it is glomerular filtration rate. Filtration rate. And the test, it is called as the inulin clearance test. Inulin clearance test. Okay, inulin, it is found abundantly. Okay, it is inulin is found abundantly in dahlia, okay, chicory roots, okay, chicory roots, garlic, and much more. Garlic and much more. Inulin, yes, is found abundantly in dahlia, chicory roots, garlic, etc. Now coming on to the difference between the dextran and the dextrin. Remember beta, the dextran, it is, okay, dextran, it is homopolysaccharide of glucose. It is homopolysaccharide of glucose. Okay, and dextrin, it is hydrolytic product of starch. It is hydrolytic product of starch. Okay, so after hydrolysis, the starch will form dextrin. Okay, now remember beta, the dextrin, it is a plasma volume. It is a plasma volume expander, and dextrin, it is an oligosaccharide. Okay, dextrin oligosaccharide है, dextran जो है homopolysaccharide है. Now when I say oligosaccharides beta, what will be the number of sugar units? Okay, I want answers in the chat box. When I say oligosaccharides, what will be the number of sugar units? I have already discussed this in yesterday's class. Yes, Rajvardhan, very good. और polysaccharide बोल रहा हूँ बेटा, तो more than 10 हो गया. पहला डिफरेंस तो यही है. ठीक है, hydrolytic product of starch, okay, and it is a plasma volume expander. Okay, plasma volume को बढ़ाने के काम आता है. That's it. Remember? Yes, yes, everyone is right. Jairam, Priti, Harsh, Alfez, Prince, very good beta. Coming on to the last one for today, that is the pectin. Now pectin beta, it is considered as a dietary fiber. Okay, it is considered as dietary fiber. It is considered as dietary fiber. It is heteropolysaccharide. Okay, it is heteropolysaccharide. Now when I say hetero, it is made up of two different, okay, two different units. And remember, it is, yes, Can anyone tell me? Can anyone tell me what are the two units that it is made up of? It is galacturonic acid, galacturonic acid plus arabinose, plus arabinose. Now, when I say arabinose, beta, how many carbon atoms will be there in arabinose? How many carbon atoms will be there in arabinose? Tell me in the chat box, beta. How many carbon atoms will be there in arabinose? And if you asked that what is the major component of pectin, it is galacturonic acid. Majority it is present. Majority it is present. Chalo. Yes, Raj Patel, very good. It is having 5. कल ही हमने discuss किया था pentosis वाला part. We have already discussed the pentosis वाला part yesterday only. Yes, Raj Patel, it is 5. So yes, Harsh, it is 5. 5. Very good, beta. Very good. Chalo, Anshum Prince, very good. Very good, beta. Perfect, perfect, perfect. Chalo, we have already completed our target for today. Okay, we have already completed our target for today. We have discussed the disaccharides, the differences between the reducing and non-reducing disaccharides. We have understand the examples, okay, of disaccharides, okay, the monomer units and the linkage, monomer units and the linkage, examples of non-reducing disaccharides with examples and linkage, the structures I have like shown you, okay, and why it is called as reducing and non-reducing I've already told you with the help of structures as well. Okay, after that, trehalose, polysaccharides, homo and hetero, glycogen, starch, cellulose, chitin, inulin, difference between dextran and dextrin, and pectin. I hope this is clear to each one of you, beta. I hope this is clear to each one of you. So just give me a thumbs up if it is clear to each one of you, beta. Today's lecture, I hope it is clear to each one of you. Yes, चलिए वाई बेटा थोड़ा थोड़ा ही पढ़ना है, थोड़ा थोड़ा ही पढ़ना है और डेली थोड़ा थोड़ा पढ़ेंगे. Shraddha beta, you can go to the previous lecture that I took yesterday. I have only started yesterday, beta. So you can just go to the previous lecture that I took yesterday. It will be in the live section video and you can obviously see that. And yeah, there's nothing much which I have like taught. So hi-fi वाला concept नहीं है, अभी बहुत basic पढ़ाया है, ठीक है. तो एक दो दिन और फिर मतलब बिल्कुल ही लेवल अच्छा खासा लेवल चला जाएगा, ठीक है बेटा. चलो फिर हम थोड़े क्वेश्चंस भी स्टार्ट करेंगे कल से टुमारो आई विल टेक अप क्वेश्चंस आल्सो नाउ. Okay, so I want every one of you beta to revise the all the two lectures, okay, all the two lectures, and like where I have asked you to draw the structures, please draw it, okay, don't leave it for anyone. It is you people only who will draw it and learn, right? So I will be asking questions tomorrow. We will solve some MCQs, right? So yeah, just revise those two lectures and come tomorrow at the same time, 6:30 p.m. I will be taking live session daily. Right? Okay, beta. Goodbye. Shania.